Hello, this is Professor Broker, and this is your Chapter 7 and 8 lecture, Welfare Economics, Part 3. And so let's go ahead and get started. Remember, we're talking about welfare economics, consumer, producer surplus. Is the market allocation efficient? How does it promote economic well-being? That's what we've been talking about. What we're going to talk about in this third lecture is we're going to apply the analysis of a tax, okay, to a competitive free market and see how that changes the allocation of well-being and surplus in the market, and what does that do to the economic well-being. So remember, our contention was that a competitive free market maximizes efficiency and total surplus. And so again, here we are. What if the government steps in with a policy designed to maybe they have some obviously goal. Maybe they want to have tax revenue to to help build a road or a school or something. But how is that going to impact our market well-being? That's the analysis we're going to do in this chapter. You'll remember from chapter 6 that our competitive equilibrium was where supply and demand intersect. If there was a tax in the market, it created a wedge between our demand and supply curve, right? Equal to the size of the tax. And regardless of whether the tax was paid by buyers or sellers, there was this tax wedge. It was the same in either case, right? And the price buyers pay was now going to be higher, and the price sellers receive was now going to be lower. And in fact, the difference between PB and PE was the tax burden on buyers, and the difference between PE and PS was the tax burden on sellers, right? And there would be a new lower, smaller quantity, QT. The size of the market would decrease, right? This was chapter 6 analysis. Now what we're going to do is we want to apply welfare economics to this analysis of a tax. So the first thing we need to recognize is, what is this rectangle right here, right? If I took if this was a per tax unit, or a per unit tax, I should say, like a specific dollar amount for every unit bought or sold, right? Then QT here, that distance, if I multiply that by the size of the tax, right, that should give me my tax revenue, which would also give me the area of that pink rectangle there. Okay, and so that rectangle there would be representative of our tax revenue in the market. Now, we're going to apply welfare economics to help us understand what happens to consumer and producer surplus, as well as tax revenue and such, in this market. Now, you might ask, how will we count tax revenue? Will that count as benefit to the market? And we will say that it will, because tax revenue can fund beneficial services like education, roads, police, so on. So if tax revenue exists, which if there is a tax, you would expect there to be some tax revenue, then we will count tax revenue as towards total surplus in the market. Okay, and so that's important to know in this analysis. Okay, so let's move forward. If I put some letters up here and I said, what letters represent consumer surplus before there is a tax in this market, right? Obviously, that would be everything above the price PE, because again, we'd be in equilibrium, but below the demand curve, right? So consumer surplus would be A plus B plus C. Everything below demand but above price. What would be producer surplus? Well, that would be everything below the price PE but above the supply curve, or D plus E plus F. Therefore, and also then I would obviously say, what would be the letters that represent our tax revenue? Now, if you think tax revenue would be B and D here, I have to remind you that, remember, this is the analysis without a tax. So what letters represent the tax revenue without a tax? Obviously no letters, because there is no tax revenue, right? If there's no tax, then there's no tax revenue. So don't let that trip you up on an exam or on your homework, right? So there's no tax revenue. What would be total surplus? Well, it would simply be that big triangle A, B, C, D, E, and F. That would be our total surplus, and that would be maximized if this was a competitive market outcome. Okay, and there's no externalities, no market power, that kind of thing. Okay, now, a tax is going to do two things, and we're going to see it very specifically in this analysis. A tax will redistribute some surplus, okay, from one party to another, and a tax will reduce some surplus, okay, reduce total surplus. Let's see how that works. Okay, now with a tax, right, What would be now consumer surplus? Well, remember, it's going to be everything below the demand curve and above the price buyers pay, okay, which would be this new higher PB. So now consumer surplus is only going to be the area labeled with A. Okay, notice consumer surplus has gone down by the amount B plus C, right? What would be producer surplus? Well, it would be everything below the price sellers receive, which is that PS line there, but above the supply curve. In this case, just the letter F. Notice that producer surplus after the tax has gone down by the amount D plus E. Okay, now, what would be tax revenue? Would there be any tax revenue? Well, sure there would be. It would be QT, right, times the size of the tax, the difference between PB and PS, so it would be the letters B plus D. Now, B plus D is the tax revenue, and that represents redistributed surplus, because here it is. B is still surplus. It was surplus without a tax. It's still surplus with a tax. It's just changed hands. B used to be value that belonged to consumers. It has now been taken from consumers and given to the government through the tax. Okay, and so it is a redistributed surplus. Same thing with D. D used to be surplus that belonged to sellers or producers. Now it has been taken from sellers, right, in the form of a tax, and it is now given to the government. And so D is redistributed surplus. So B plus D represents redistributed surplus. Okay. Now, total surplus is only going to be A plus B plus D plus F. Okay. Obviously, total surplus is smaller than with the tax than it was without the tax, right? And it's smaller specifically by the amount C plus E. And you might say, well, why don't we count C plus E? Good question. Because those are units that no longer take place. These are not units that are produced anymore. They were produced without the tax, but they're not produced anymore, and they're not bought, obviously, by the consumers. These are transactions that used to, take place. The product was produced and the buyers consumed them, and there was value, consumer and producer surplus there represented by C plus E. But now they no longer take place. They've vanished. Okay, they've been essentially destroyed by the tax. Okay, we call this deadweight loss. C plus E represents deadweight loss in the market. Okay, because of the tax, it is the fall in total surplus that results from a market distortion. There can be multiple market distortions, such as a price control or so on, but in this case, the market distortion is a tax. Okay, and a tax will reduce the size of the market, and in so doing, will destroy some market efficiency. Okay, now maybe it's policy, maybe there's a good reason why we want to do that, but it will in effect reduce total surplus and reduce economic well-being in the market by that amount, and we call that deadweight loss. Okay. And I basically just said this, but essentially, the value to buyers that you can see in the distance between QT and QE, the value to buyers represented on the demand curve there is greater than the cost to sellers. So it's destroying these transactions, and the reason that reduces total surplus is because if those transactions took place, the value to buyers would be greater than the cost to sellers. In other words, it would add to total surplus. But the tax prevents those transactions from taking place because it prices the price too high for those consumers, and it prices the price too low for those particular marginal producers, therefore preventing mutually beneficial transactions. Okay? And so again, total surplus is always going to, in a competitive market, total surplus will always be larger. Efficiency will always be larger. Economic value will always be larger in a market without a tax compared to a market with a tax because of the deadweight loss. So taxes redistribute surplus, and that's represented by the tax revenue. Okay, that's still surplus, but it's just been redistributed. And a tax will reduce surplus as well, and that's represented by the deadweight loss figure. Okay, and this is an excellent actually representation of what we talked about in chapter 1, where we said there's always a trade-off, right? One of the big trade-offs in policy is the trade-off between efficiency and equality, right? Obviously, if we tax a market, we're going to try to use the tax revenue probably to try to generate some more equality, right? Maybe through some transfer programs and what have you. And so that tax revenue can potentially increase equality. But just like we've done in this analysis, what we've shown is you can only gain that potential equality by reducing some level of efficiency. So it's a trade-off, right? That's what we need to recognize. It's not saying that we shouldn't tax. Taxes are a part of life. It's just simply saying that there's a cost to that tax. And so yes, maybe we want the tax revenue to try to do some good things, but there will be a cost to that. And we represent that here in the form of deadweight loss. Now, what determines the size of the deadweight loss? Okay, well, it's going to depend on the elasticity of supply and demand, right? It's going to depend on the elasticities because basically if we tax a market that market participants can easily leave, okay, that's going to have one implication for deadweight loss versus if we tax a market that consumers can't leave very easily because their demand's inelastic, that's going to have a different implication for deadweight loss, okay? So let's assume we have a relatively inelastic demand curve, say like insulin, and we decide to tax this market, right? That would obviously be very cruel, but what would that do for deadweight loss? Well, if demand's very inelastic, it's going to be very hard for consumers to leave the market when the tax raises the price they have to pay. That means that you're not going to have a much smaller, you're not going to have a very large reduction in the market quantity. Therefore, your deadweight loss will be very, very small. When you tax goods with relatively inelastic demand or inelastic supply, you could anticipate a very small deadweight loss. That means that those taxes would be relatively efficient. Okay. Obviously, you can also imagine though that taxing insulin, goods with relatively inelastic demand, would be taxing things that people need, and so that would also probably be somewhat unequitable. But it would be very efficient because the deadweight loss would be very small. Versus taxing something with more elastic demand like luxury cruises. Right? This would be a very palatable tax for the public to accept because it's like, well, people don't have to go on cruises, right? But what we have to recognize is that it would be very easy for buyers to leave this market because of the elastic demand. Therefore, the same size tax in this market would actually reduce the size of the market by a larger amount, therefore generating a much larger deadweight loss. Okay, so markets with more elastic demand or elastic supply, we would anticipate would generate much larger deadweight losses, meaning that these taxes would be much less efficient, would raise less revenue, and destroy more beneficial transactions. Now, let's just say that we start with a basic size tax. Okay, we've taxed this basic market, right? Tax size T. What would happen to the deadweight loss, say, if we doubled the tax? Okay. Now, visually, right? So the tax itself, say, has doubled, say, from $10 to $20. But in terms of the value, the economic value destroyed in this market, in other words, the size of the deadweight loss, you can immediately visually see that the deadweight loss would more than double, right? The deadweight loss would more than double. Okay? In other words, and if we tripled the tax, the deadweight loss would more than triple. Okay? Just because of the shape of the supply and demand curves. Okay? So in other words, the relationship between the size of a tax and the deadweight loss is actually an exponential relationship. Okay? When tax rates are low, raising them doesn't probably cause much harm. And lowering them doesn't bring much benefit. But when tax rates are already relatively high, raising them can be extremely detrimental and very harmful. And if they're really, really high, cutting them or slashing the tax rate could actually be very beneficial. But again, it depends on its relative starting point. Okay? Now, let's do the same sort of thought process with revenue. So here we have our initial tax, and we have a certain amount of revenue, represented by the yellow rectangle. If we double the tax, well, what would happen to tax revenue? Well, the tax revenue probably would increase. Okay, probably would increase. Maybe it wouldn't exactly double, but it would at least increase. But you could imagine a point where, say, tripling the tax or quadrupling the tax gives you actually a much smaller revenue rectangle. In this case, the blue rectangle would be much smaller in value compared to that to the red rectangle. Okay, and so in other words, as you increase the tax rate, okay, tax revenue might initially increase, but you might reach a point where tax revenue actually might go down because the tax rate destroys so much economic activity that it's just not going to be able to generate enough revenue. This thought process is the thought process behind the Laffer curve, or the intuition behind the Laffer curve, okay, which is the idea. It basically describes a relationship between tax revenue as well as the tax size. And the implication is that when you start over here at the origin, with very small taxes, and you increase the size of the tax, you're obviously going to increase tax revenue. But the implication is, based on our market and the structure of supply and demand and the nature of supply and demand and the nature of deadweight loss, that you can increase the tax rate so much that you might reach a point where tax revenue actually peaks. Right? And then increasing the tax rate beyond that actually can decrease tax revenue, not increase it. In other words, if I'm over here, on sort of the right half of this semicircle, that actually decreasing the tax rate could potentially increase tax revenue. That's at least the implication. Now you might ask yourself, well, what would be the tax rate that would sort of peak this tax revenue out? And of course, there's various estimates. There is no one specific number. And in reality, for example, U.S. tax rates, I think most economists would agree, we are probably, given the tax reductions over the 1980s and some, since the 1980s and so on, we're probably on the left side of this Laffer curve, of this semicircle right now, where decreasing tax rates probably would decrease tax revenue, and increasing them probably would increase tax revenue. That's, of course, no indication about what we should do. That's just representing a positive analysis of the situation. But nonetheless, this is the idea of the Laffer curve.